Good morning, everyone. Welcome to the webinar. We're going to give another minute or so for the late participant to join us, and we'll kick it off in a minute. Good morning for everyone that joined us so far. We see there's some still people are trying to log in, so we'll give it another minute or so, and we'll start. Thank you for your patience. All right. Good morning from Washington, D.C. to everyone that joined us this morning. With me today are partners, colleagues, and friends that were gracious enough to join us and to make this webinar possible. Before we kick this off, just some housekeeping notes. The first thing, everything you're going to see and everything we're going to talk about is completely unclassified. I know that we have some people that joined us that have this question in mind. So rest assured, nothing is with any type of classification or sensitivity within it, completely unclassified and fully commercial. The next thing, we're going to show some examples and some use case. Please be sure to tune in, see them all. I'm sure that both ICEYE and Planet will be more than happy to share their portion with everyone that wanted to follow up and ask for the presentations. Q&A session will be the last thing we're going to do. If you have any questions throughout today's webinar, please don't hesitate to send them over, and we'll do our best to cater and to answer them. So let me start by, first of all, greet everyone in and thank you for joining us. My name is Matan Peled. I'm one of the co-founder of Windward. And today with me are Matthew Morris. He's the Director of Defense and Civil for ICEYE, and Marc Peña, the Senior Customer Success Manager for Planet. Also with us are Guru Sender. He's the Product Manager for Intel Products, Integration, and Data. And as I said, my name is Matan, and I lead the U.S. business side of Windward. For me, this is not less than a dream coming true. I'm very much love the fact that we can do this together. I truly believe in the companies, both Planet and ICEYE are leaders in their fields, and this is incredible opportunity to talk about how everything can work beautifully together. Gents, remote sensing has been a technology that was around for many years. I'm not sure how many of our attendees are aware of the differences and nuances between different remote sensing capabilities. And I think maybe before we start, if I can pass the baton to you guys and maybe to ask you to share some more intimate details about what ICEYE and Planet provide, that can be a good start. So with your permission, Matthew, can you kick this off?
Sorry, I had to figure out how to unmute my screen, of course, every time that gets me. All right. Good morning, everybody. Many thanks for joining us today for this webinar and for spending some time with us as we discuss a very relevant topic, in this case, maritime domain awareness and how we can bring in multiple remote sensing phenomenologies into a single common operating picture to provide a final fused intelligence product for decision makers, warfighters, analysts, and industry. I'm ICEYE's Director for Defense and Civil, and I come from a military and intelligence background before I joined ICEYE. And today I'm going to shed some light on ICEYE's capabilities and showcasing a little bit about how we support maritime domain awareness efforts. Just basically a little bit of an ICEYE 101 and SAR 101 for you. Next slide. All right. ICEYE builds, operates, and maintains the world's largest commercial synthetic aperture radar constellation with over 24 satellites in orbit today. By the end of calendar year 24, we're going to be pushing about 40 birds in orbit to include generation 2, 3, and 4 satellites with ranging capabilities. This robust constellation brings customers the highest revisit rate across the globe with the ability to collect day or night through cloud cover anywhere on Earth. Perhaps just as significant as our high revisit rates is our resiliency, because we have such a large, robust constellation. When a satellite requires software updates or requires an unscheduled maneuver in orbit or reaches its end of life, we always have a selection of operationally ready satellites to provide collection in its place. You never have a gap. Or let's say, when and if that day comes that our adversaries start taking action against commercial satellites, having this very robust, very large constellation is going to ensure that we always have a plan B, C, D. We always have a contingency plan to ensure that we're providing seamless, uninterrupted support to our customers. ICEYE provides the widest variety of imaging modes in the commercial SAR domain to include huge scene sizes of up to 40,000 square kilometers, all the way down to 25 square kilometers without sacrificing resolution, which you'll see in a few upcoming images, because that's what we all like to see, is the pretty pictures and not listening to me talk. All right, we support imagery analysis, we support industry, analysts, warfighters, and decision makers with our sub 1 meter resolution, and we'll soon improve upon that capability with our larger scene sizes and even greater resolution with the rollout of our generation 3 satellite imagery later this year. All the aforementioned capabilities are wrapped up in a nice package and delivered to our customers in just a few hours. Next slide. All right, so in brevity, I discussed some of our capabilities, but really let's showcase a few of those images that I discussed that we provide our customers on a regular basis. In here, we have our pretty pictures, right? But it's not really a photograph akin to optical imagery. It's synthetic aperture radar, right? So it's radar bouncing back and forth, or bouncing from the satellite that goes up the satellite and eventually gets downlinked to a ground station, post-processed, and delivered to our customer. In this image, we have a major vessel shipping lane off the coast of UAE to capture with ICEYE strip map image mode. You can see a large number of vessels in this image, but when correlated with AIS data, we've noticed that a few of the vessels are not emitting their AIS and have gone dark. What adds more variable to this image are these large smudges that you see in the water. Those are not image anomalies, rather those are oil spills near the Fujairah oil terminal. You can see here, basically, we've got vessels that were detected or that were captured in the SAR image that were not emitting their AIS signature. So that typically does is a tip and cue mechanism, which draws us to explore these vessels that were not emitting an AIS signature to see if we can further maintain chain of custody and catch them doing something nefarious or illegal or suspicious in the future. None of this would be possible without fusing that with some sort of AIS data, right? SAR is not going to be able to do that analysis by itself. Next slide. All right, the image here was also captured with ICEYE strip map image mode, which comes in at about 30 kilometers by 50 kilometers scene size at our 3 meter ground resolution, which is not even our best resolution mode, but it does provide a nice large scene size for maritime applications. You'll see here that we have 2 vessels, one of which we had been monitoring with a combination of AIS and SAR data, but the vessels eventually went dark. Fortunately, we were still able to provide some analysis to predict where the vessel was going to be located on the next satellite path, and we're able to corroborate a ship-to-ship transfer, likely smuggling oil, which is so common in this region. Next slide. And our final image of the day, I wanted to share a beautiful example of our recently released dwell image mode. The dwell image mode is derived from a 25-second long dwell collection and is processed with a cutting-edge processing technique that enables the extraction detail that is not possible with previous collection modes. Dwell imagery collection is best suited for precise object detection to include vehicles, aircraft, and especially vessels, whether that be in port or open water scenarios. And you can see in this image, we have very nice, clear, granular products that images that you can provide. You can very clearly see those vessels that are docked in port, and the same application can be applied to big open water scenarios and things of that nature. Currently, our dwell image mode comes under 5 kilometer scene size at 1 meter ground resolution, but due to the clarity and the lack of noise in the background, it actually gives a perception that's greater than 1 meter ground resolution. Now that ground resolution is actually going to be cut in half here in just a few months when we release our Generation 3 satellite imagery. So you can really imagine how exquisite that imagery is going to look coming from a very small commercial-based satellite. All right, next slide. All right, so of course, I'm very proud of ICEYE and what our SAR capabilities are, but it must be noted that no single tool provides a full picture of the operational battle space. To achieve persistent awareness in the maritime domain, military and law enforcement organizations must pursue comprehensive and holistic tactics. This includes the fusion of multi-source intelligence from both national and commercial means to provide a timely and accurate depiction of open sea activities, ideally integrated into an interoperable common operating picture, which in this case is provided by the great folks at Windward. The luxury of commercial remote sensing data is that it is infinitely shareable to our allies and partners, right? It's completely unclassified, which is something that we typically cannot do with national technical means or federal level exquisite types of collection or remote sensing. Never before has the persistent data and seamless integration to the intelligence cycle been so readily available, but we're happy that we're working here together. We're finding multi-source, multi-ent approaches, and we can actually just a bunch of smart people behind computer screens working in the commercial industry and not in a skiff. I use the term smart loosely when I refer to myself. But we're able to put these things together and deliver a final fused, clear, cogent product to our industry, to our analysts, to our warfighters, and our decision makers. Any questions?
I guess we'll have time for questions, and if anyone has something that you can address now, I'm sure that Hila or Gur will flag this. My only comment, Matthew, and I think that ICEYE is not just a leader in its field, it's DNA and approach to the challenge, and to see the men and women in the front has been something that is very humbling and a great way to understand who are the people that drives it. So we're very humbled to work with you guys, and thank you for this amazing presentation and for your friendship and partnership. Marc, Planet has been around for as many years as Windward, if not more than that. You guys are the GOAT in everything that is electro-optical, and you lead by example. And I would love, with your permission, maybe to pass the baton to you to speak about what makes Planet such a great company and so uniquely positioned with your offering.
Thank you very much, Matan. And yeah, very excited to be here. Very excited to share the stage with you. We have a long-term partnership. And as Matthew also pointed out, this is all about combination of data sets, and what Windward is doing in terms of that, and merging those data sets and making them easily accessible to end users. You're the GOAT on that point in maritime domain awareness, I have to say that. And yes, thanks for the introductions as well. So who is Planet? If we can go to the next slide, we can start with our mission, which is to image the whole world every day and make global change visible, accessible, and actionable. This was also formalized during when we went public and implemented our public benefit corporation. and this also and the purpose of it, right? And how we combine and speaks both the sustainability and global security, but also cements on how our business and impact are aligned. So how we go about this mission? We can go to the next slide. This video shows our current constellations. The one on the left is our PlanetScope constellation, which is made of the SuperDove satellites. And on the right, we have, you can see the orbits and synchronous orbits. And these satellites are always on and scan almost the entire landmass every single day, providing imagery at 3-4 meter resolution within 8 spectral bands. On the right hand, we have the SkySat constellation, which is a most traditional testable constellation, where you indicate the location and timeframes that you desire for your target. It provides imagery in 4 spectral bands. The first opening image that we had for this tech was a SkySat image, and it provides in the visual and near infrared bands within the spectrum. The spatial resolution, it goes down to 50 centimeters. If we go to the next slide, we can dive a little bit deep into each of these elements. So again, on the left, we have the PlanetDove satellites. We have around 180 of them, and their weight class is about 5 kilograms and provides 8-band imagery. On the right side, we have the 20 SkySats we have in orbit. It's 100 kilograms class satellites, and it provides responsive tasking multiple times a day. They're large as the size of a fridge, and are designed to be very agile, so they can reorient and take a picture of a target in a few seconds. And together, PlanetScope and SkySat are a very powerful tool for tip and Q applications, and this is our main differentiator. We can use the always-on and high revisit frequency of our PlanetScope to monitor wide areas for surveillance activities, pinpoint areas of interest based on change, and then task the SkySat satellites over those AUIs to increase the level of detail of information. And furthermore, it's not only about imagery, it's about how easy it is to access those workflows and to implement those workflows. And we have enabled ease of access through our APIs as Windward has been using so far. If we can go to the last slide. In addition to this, the result of both these constellations working together is a vast archive of imagery collected. We have more than 2,000 images for any given location on Earth. And this provides a deep historical context for temporal analytics, machine learning training models, and app development. And yes, that's it from my side. Thank you very much. And if you have any questions, we can also address it by the end of the webinar.
Thank you so much, Marc. This is amazing, and I think that what Planet was able to accomplish is super unique and incredibly valuable. So thank you again for the great partnership and for presenting today. I see there's already some questions, but just in light of time, I will, with your permission, wait for the Q&A session, and we can come back, and I'm sure that both Matthew and Marc would love to try and answer everything that you have. So without any further ado, I want to say that looking back, when Ami, my co-founder and the CEO of the company, and I started using remote sensing, it was I want to see almost 13 years ago. It was in infant stages. And today we hear many solutions in the market. A lot of people know and use remote sensing data. Sometimes it's a bit hard to kind of differentiate or separate the wheat from the chaff. Maybe I can ask you, gents, to share your perspective about the changes we see in the market and maybe the increasing need within the industry. If I can start with you, maybe Marc, it would be interesting to hear your perspective.
Yes, I mean, obviously, I think Earth-based Earth observation, space-based Earth observation has undergone a tremendous transformation during the last 20 years, and with having like agile space systems like small satellites coming into play and showing their value has transformed the industry completely. We are working specifically in the maritime domain awareness in an environment which is highly changing, monitoring wide areas, and definitely remote sensing technologies have brought a lot of value, and they've shown it about it. This has also like come together with the availability of data with other data sources like AIS. AIS also has been enabled thanks to Earth-based, to space-based technologies. AIS had a physical limitation in terms of the range of VHF signals, and that was enabled thanks to the space-based. But then we brought a lot more of spectral combinations that gives information, right? Yep. And in this industry, yes, we see that not only one single data source is going to resolve a question, we're going to need many of them. And together with that need, together with the proliferation of data suppliers in the market, has eased the access to that data, not only on commercial levels, but also with all these commercial players at base. They have been thinking about how we make it easable and easy to access this data, these large data sets, and then where Windward comes to play, right? Like how we make them all together, right? How we make it digestible for end users.
No, this is awesome. Matthew, love to hear your point of view, especially kind of coming maybe and separating the wheat from the chaff. And if you can address kind of how you see the industry evolve. I know that you're not just a leader in your field, but was also a few years ago kind of in the other side of the coin. So it will be interesting to hear your perspective.
Yeah, sure. I think the most notable thing is just, I guess one of the things is just the advancements in technology, right? So I came from a military and the Marine Corps background, and then later transitioned to being a federal civil servant that especially, mostly worked in the special operations community, the intelligence community for darn near 2 decades. And, I remember some of my first deployments in, various, austere places. It was a struggle to get like 10 and 15 meter CIB data, and we're supposed to do targeting and fires and chase bad guys and do all these things with this data. And we always thought it was like really great. And, now, I mean, we've got commercial folks providing sub-meter, sub-half meter at times ground resolutions, both optical and SAR. So that in itself is just like truly amazing, right? Like the type of data and the quality of data that that warfighters and analysts and decision makers and industry are able to get at their fingertips for a very reasonable cost as well. It's there, and they're not waiting on competition from national technical means. And I guess team is probably a U.S. specific term, but federal organic resources, right? That typically can be scarce depending on where your priority is on that food chain, or whatever, policymakers deem as that priority of the week, right? But now folks are able to leverage commercial ISR and commercial remote sensing, which is just a really fantastic phenomenon and a great revolution. And SAR almost even more so, because I don't think the first commercial or the first government SAR contract wasn't even, I think, in place until like 2019. And the states for a long time, U.S. military and the intelligence community pushed back on commercial SAR and wouldn't let it come to fruition. All right, yep. And now we've got a few companies that are providing really great products, and ICEYE, emerging from across the pond and now here with a U.S. subsidiary, and we've doubled our personnel just in the last year, and we've emerged into this intelligence market and the DoD market and commercial industry, Predictive, and just seeing that it wasn't that long ago where the government kind of said, hey, but you know what, like you're stepping on our toes, you've got your spoon in our bowl of Wheaties, this is our job, please stay out of the way. And now they're like, please come help us. Like, we're going to find a path, we're going to find contract deals, we're going to find mechanisms to ensure that your data can be seamlessly integrated and provided to our strategic and tactical end users. And even more so, that's evolving now because again, being an intelligence professional for a long time, you're not just a human guy, or you can't just use HIMIT or just use SIGINT or just use imagery, right? It needs to be multi-ent. You have to corroborate that. You're never going to take action on a target based off of one stream of information. And now we're bringing something like that together to the commercial space, which is, let's face it, like the government wants a turnkey product. They want to be spoon-fed information, and that's something here. And I think the government really didn't know how to ask for that from commercial, but with all of us with our diverse and comprehensive backgrounds, we will be able to put some of this stuff together and showcase it to them, and they say, oh, that's actually really checks a lot of boxes that we have, and now we don't have to build that architecture internally. So I like the evolution. It's moving quickly and at a much faster rate than what any national or regional or international government can move over.
No, that's super insightful. I guess one of the many reasons that we love working with both Plant and ICEYE, I think it's the scale and the game-changing data, and obviously factors like revisits rate and time to acquisition, specifically in the maritime domain. This is a key because things move, right? Versus land-based applications. So interesting maybe to ask from the perspective of the users, what are the main challenges that you guys see that you try to cater for on the maritime side? If you can address this for a second, maybe Matthew, you can maybe add some more insight on the challenges coming from the ecosystem.
Yeah, there's a few. And again, I think the people on this call are probably very aware of them. Those of us that are speaking today are very aware and trying to find some of those solutions. But there's a lot of data out there now that we've talked about with commercial industry has grown. But there's still a challenge on what do we do with this data, or that we as end users in general, right? How can they get this data? How can they aggregate it and integrate it into a system? There's a lot of commercial providers that are providing, data aggregation services. There's government that can't decide whether they want to use their own or buy somebody else's. So these are struggles. And there's also, a lot of, with that, like what do we do with the data is the analysis part, right? So that OODA loop, how can we expedite that decision-making process for analysts and decision makers? And that's, employing some sort of analysis onto that data, whether that's the data itself or the ones and zeros behind that data. And I think that's something that's coming into play with the AIS and the maritime insights that Windward actually provides with both optical and SAR, is that you're able to provide the AIS data, right? And then you're able to provide the insights and pattern of life and behavioral analysis. You're able to combine all of that data into a single repository, a single, interoperable common operating picture that I noted in the introduction. And I think that's helping solve some of those problems that the customer said, oh, wow, like we've never had this much data in our life, right? We've always had to fight for data through federal or national technical means. Now we're able to get our hands on a lot of commercial remote sensing data, but what do we do with it? How can we get it in? How can we get seamlessly integrated? And how do we employ the horsepower to analyze that? And no, humans in the loop are always needed, but humans in the loop are not necessarily going to be able to expedite that process of the analysis. And I think that's where the artificial intelligence machine learning protocols are coming into play, and that's helping solve a lot of those problems. There's many more I could go on, but I think nobody really wants to listen to my voice right on for that long.
No, I think again, it's a valid point, and the fact that I think that what's unique about what we're trying to achieve is to climb up the value chain and introduce not just the raw data, but actually the actionable insight and things that can be operated against, and not just another layer of data. And I think it works beautifully. Marc, same maybe question to you, sir. Like I'm sure that part of the DNA of Planet that I really like is asking questions all the time. Like, what can we do better? What can we change? Can I ask you maybe to share your insight about the challenges coming from the ecosystem that you see?
Yes, sure. Thank you. And I think one of them, it was already mentioned with Matthew, there's a vast amount of data, but this was not a challenge some time ago. It was a challenge of a very established industry where it was followed by very operational procedures that were hard to change, and where we've been working very hard to show the value that these data sets are bringing, right? Specifically on the maritime domain awareness, where we starting to look in very vast areas where we need to pinpoint these activities and start big and then narrowing down. We've been proving the value of our technologies. That was one of the main points, like, okay, AIS is there, other data sets like RF location is there, but what else we can add to the picture? Because at the end, also, that was one of the main points, but also for analysts to understand not only which is capabilities and performances of each data set, but also which are the vulnerabilities and how they all work together to bring a common picture to the analyst and make this time to insight very quickly. I think this is one of the main challenges that we saw, that we proved value on solving those questions, merging several data sets, and we moving forward there as well.
Yeah, absolutely. I think this is my sole opinion, but I'm sure that it's gonna be the same with many others like-minded. Both ICEYE and Planet are leaders in their field, not just on the data side, but also in the ConOps and developing things that go beyond the data itself. Driving kind of intelligence decision, and I think this is part of the reason we gather here today, and kind of moving from a singular source to a multi-int approach is something that we strive to achieve. And maybe it's a good point of time in this presentation to maybe ask Gul to present some of the mutual use cases that we build together with Planet and ICEYE. I think this is not just a testament to everything we discussed so far, but a real life use cases that show how everything play nicely together. So unless you have any specific comment before we move into the show and tell portion, I'll pass the baton to Gur. So Matthew, Mark, anything before Gur starts showcasing some stuff? No. All right. Mr. Sander, take the floor.
Thank you, Matan. It is a real pleasure being here today with this respected forum. Today, I'm going to present to you two different use cases that we prepared together and task dedicated assets specifically for that. So the first one will be detecting and classifying foreign operations in the Philippines EEZ. As part of the Great Power Competition, a leading navy received the following mission with two objectives: obtain evidence of illegal Chinese presence in the Philippines EEZ and classify the vessels operating in the Philippines EEZ. Now, that might sound like a simple task in different areas, but when we look at the task itself, there are several challenges there. The first one is that the South China Sea is an area that is often covered with a lot of clouds. Second, deploying assets such as planes, vessels are expensive, revealing in some cases controversial. Third, in some cases, obtaining visual confirmation is a key for double verification as an objective of task. Last but not least, once you decide to task some assets, there is a big question: where and when? How would you time it and where you want to deploy it? And that takes me to the next point. When we're approaching tasking, it is important to remember tipping and queuing is a matter of probability and opportunity. If you're aware of the odds, you can place your bets in a calculated way, just like any movie about blackjack where players are winning against the casino. So without further ado, let me share my screen and take you through the actual workflow and how it's done. And you'll see my screen now. Okay, I'll assume that would be it. So now you'll see the Windward search engine where you can start structure queries, questions about vessels, activities, and locations. So we are looking at the Philippines EEZ, and the operations are related to military law vessels under the Chinese flag. As this task was done in the past, we're going to search for activities related to past events. So searching for operations in slow speed activity. Now you may wonder why. So slow speed activity is indicative of patrolling, research survey, construction operations, or other maritime operations as they're taking place in slow speed. Secondly, we'll select the Philippines EEZ, and the time range will be custom time range that is looking from Jan 1st to the end of February. So searching, that's a query that I've already ran the search. So those are the results. We can see that during January and February of this year, 4 military law vessels under the Chinese flag conducted over 190 events of slow speed activity. So when looking now at the area, it is quite clear where do we wish to task the relevant satellite in order to gain the asset. So this is the area. Let's focus on the first vessel, clicking on it, highlighting the relevant activities. We can see the name of the vessel is China Coast Guard 3301. Picking the activities and displaying it over the map itself. Now we can see the operations of the vessel, and we can drill down to better understand what is the timeline we're looking at and what is the time range we have for tasking. Now we are overlaying the vessel over the map, zooming in, hovering over the vessel's operations, and we can see that the time of arrival, the vicinity of the area, it was on January 7th, 5:30 p.m. Zooming out, focusing on the area where the vessel departed from, we can see that the time of departure is January 6th, 3 a.m. So we have a time frame of about 36 hours for deployment, which is sufficient, as ICEYE standard tasking is about 24 hours for tasking. So now you probably wonder, why did I create this relatively larger polygon around this dock? Loading is a static satellite layer we have right here in the system. We can see that this dock is populated by non-commercial vessels. So that gives me the indication that any vessel departing from this area might arrive at the vicinity of that area, and we can monitor that. Now we have when, we have where. Now the big question is, how are we going to time it? How are we going to be aware of that? So I've consumed an alert for a vessel, for the military law vessel departing from this specific dock. That would be my trigger for tasking. Now let's look at the results. So this is again our map, and right here you can see where the asset was loaded. Zooming in, we can see that we have the SAR image available right here in the SAR overlays. First of all, we can see it is a beautiful asset. We can see 2 larger targets sailing in a structure. We can see the wake of the vessels. We can see smaller targets right here on the edges of the shoal. Now, again, this is a great image, but as stated before, by itself, any of those assets in the system is great, but the value in the combination of those assets together with the AI-driven behavioral analysis based on fused data is key. What we see here, I've looked at the position of the vessels. Right here, we can see that those 2 vessels sailing in a structure are flagged as military law. One of them is operating under the flag of China, and the second isn't. We can look also, we can zoom out and focus on the vessels operating at the edges of the shoal. Hovering over them, we can see most, if not all of them, are Chinese fishing vessel operating right here on the shoal. So let me wrap it up what we've just witnessed here. So in this workflow, we've overcome all the challenges mentioned above. So ISAR technology was selected to make sure that no matter what will be the weather, a visual confirmation will be provided. The objective of the mission was achieved without deploying any assets directly connected to the specific unit. Third, the tasking was successful. The SAR image captured the required image. The result was achieved as direct work by the combination of conducting behavioral analysis of AI-driven insights and the SAR image together. Visual confirmation was obtained here in this case. Now, let me add on that, we were lucky. It was a non-cloudy day, and we can also load the planet overlay we have right here, overlaid with the planet daily optical image. Zooming in, you can actually see the structure of the vessel, the pointy bow and the wake raised by the vessels. Now, this is a clear cut that we're talking about military law vessels according to the structure. Now, that was the first use case that we've structured together. The second one is around a different use case, different mission, different tasks, and it is highly relevant according to the latest news. We have the 11th package of sanctions released only a couple of days ago, and now we're looking at tanker operations supporting sanctions evasion in the Arabian Gulf. So in this mission that we've created, Navy forces operating in the Arabian Gulf received the following lead. We've got an indication that suspicious illegal dark bunkering operations is taking place in Iranian EEZ just off Fujairah. The mission is to identify the tanker engaged in bunkering operations in this location. Now, again, that might sound like a relatively simple mission, but right here, there are big challenges. First of all, investigating and contextualizing historical events is difficult because you cannot task assets historically, and it is hard to obtain data historically for events that already took place. Second, we wish to stay under the radar and not expose ourselves. Third, events involving dark vessels tracking, non-transmitting vessels meaning, can be challenging for investigation. Last but not least, if we want to deploy vessels or airplanes to the vicinity of the area, we first need to understand what are we stepping into. So now we know from the mission itself that we're talking about bunkering operations, so we'll be searching for bunkering and oil chemical tankers, oil product tankers. Great. So we're looking for those subclasses that were engaged in dark activity in Iran EEZ, say, in the past 2 weeks. Searching that, again, this is a query that I just ran already, and we're looking at the spread of the dark activities of those specific subclasses in the Iranian EEZ, and we want to focus on this area that was defined in the mission. So looking at the results, selecting one of the vessels, the Compton, operating under the flag of Palau, oil chemical tanker, length 118 meters, conducted dark activities for over 15 hours, just 11 days ago. Clicking on the vessel name, activity will open it up over our interactive map. Now, when looking at the operations of the vessel, we see there are several anomalies, like this aimless journey to Oman, and those aimless voyages to Iran EEZ. Now, again, this looks like an anomaly, but the question is it anomalous for this specific vessel? Now, what I've done is I've overlaid the vessel's path with his full historical operational pattern starting from December 2012. We're talking about 11 years of historical data overlaid right here, and we can clearly see this is not the first, second, or third time the vessel is engaged in such operations. Now, what I would like to do is to zoom in right here on the operations and overlay that with all unselected vessels, meaning all vessels that are operating in this area, and see maybe if there are only one vessel here, I can correlate and say, this is the vessel that it was engaged with. Clearly, it's not. We can see two closer vessels right here. Let me hover on top of them and click on them, and we can see them. Great. So now let me turn off the layer of unselected vessels. And now, in order for me to contextualize and understand what went down in these operations, let me overlay that with Planet optical satellite imagery. Let me zoom out and check the availability of images for this time. You can see the vastness of the images available for this specific date. It's all under the same date, and see the different times of all the images. You can understand the number of satellites passing there and their availability, which is amazing. So zooming back in and narrowing down the search for only tiles on this area, overlaying the image and indexing it according to the timestamp, we can see a very interesting story. First of all, we can see right here an engagement between two vessels in ship-to-ship operation, and we might suspect that there's some problem with the correlation. It might be this vessel, the global running engaged in the ship-to-ship operations. So the answer is no, because this vessel at that time was flagged automatically by the Windward intelligence system for being engaged in global navigation system spoofing. This vessel is not here. Was flagged automatically by the system. So let's continue our investigation to confirm that the company is the actual vessel engaged in ship-to-ship operation within Iranian VLCC right here in that location. Zooming in on the vessel, using our toolbox for checking the size of the vessel, measuring it. We can see, one second, yeah, we can see the dimensions of this vessel, 1 second. Stern to bow, we can see that the size of this vessel is 120 meters, which is almost perfect correlation to the vessel size. And in addition, when we're looking at the vessel draft changes for this time range, we can see that the vessel draft was decreased just a day later from 7.5 meter to 6 meters only in this specific event. So let's summarize this event and wrap it up. So clearly, the challenges were overcome in this case. We've investigated and contextualized an historical event without tasking any assets in advance or during the investigation. We stayed under the radar as we only consumed what's already available in the system. We overcame that the vessel was a non-transmitting vessel by overlaying the investigation with the Planet daily optical images. And to add on that, we got a validation and discovered that there is a a vessel engaging global navigation system spoofing right in that location. There's only one thing I want to add after presenting those two use cases, is that this is a clear case of 1 + 1 = 5, not 2, not 3, not 4. The power of the multi-source approach and combining maritime-driven AI insights with assets provided by satellite tasking and the daily optical images are just outstanding and groundbreaking, in my personal opinion.
I definitely share the sentiment, and thank you, Gur, for showcasing. I think this is amazing stories, and without both companies' unique data sets and availability, this would never be possible. So again, a great testament for why everything can work nicely together and should work together. There's tons of questions. We're definitely not going to be able to answer them all, but maybe let's start to address them one by one. Matthew, the first one is for you, sir. The question is that one of the images that you presented in your slides looks that the vessel is a horizontal direction and how you do that. Not sure if I understand completely, but maybe you can get it. The horizontal versus vertical, I assume. And the second part of the question is, do you provide a combined data that includes the SAR with other remote sensing and the multi-in? So I think we addressed the second one, but if you can say or address the horizontal part, like the direction of the vessels or the...
Yeah, sure. Sure. So I think the question is that, one of those images, instead of it looking like the satellite was taking a top view of the vessel, it was almost like this was a vessel and you're taking the image from here, for example. I know this is a bad demonstration of my hands, but what that is, that's just a kind of an off-spec look angle. So instead of the satellite being directly overhead, they were further away, or not further away, but at a harsher angle, which provided that for a vessel detect or for a vessel, profile was actually really good for, for eyeballs to see the silhouette of that vessel. And for AIS data, I mean, I'm fortunate enough to have really great contacts with Windward to where I really just tag them for all my AIS needs on a regular basis. And then they go above and beyond and add their maritime insights to that to add some analysis and pattern of lie. So that's generally my SOP.
Awesome. I think the next one is for you, Marc. If you can talk about the latency and if there is any agnostic approach to how do you overcome the latency, basically. So I guess this can be to both you and Matthew. Do you want to start, Marc?
Yes, I can start. I think the first thing to overcome latency It's with the tasking itself, reducing the time to tasking and having those satellites available to capture imagery very quickly from the time you get any alarm or any insight about any suspicious or any incorrect operation. And then in terms of that, like having also a great network of ground stations as we plan to have, like allowing you to download the data quickly and then making it available as quick as possible, and also highly fast processing algorithms to process the data and make it available. We're also working on higher latency constellations, as is Pelican, which will have not only higher resolution of 30 centimeters, but also will reduce significantly the times of latency from today that we are talking about 2 hours with the SkySats down to a lower number that we can discuss if somebody's interested in. And that's where I see where we can act.
Yeah, awesome. Matthew, do you want to take the latency part as well?
Yeah, sure. I mean, so there's various things that we can do to improve latency. I know from an ICEYE perspective, we have a standard delivery time, but we also provide some expedited delivery windows for some time-sensitive, customers, specialized customers, whether that be a military or an intelligence community type customer. And those can certainly be discussed directly with us offline. But also we're exploring other things, right? Through, a seamless API delivery in the future, obviously looking at direct downlink potential with our various government customers, so on and so forth. So always looking at that, but also improving the bandwidth of our satellites. So our generation 3 satellite is going to be basically twice as fast processing speed as our generation 2 satellites, which have been the workhorse for the last few years. And we'll be able to start rolling out that data and capability here in just a few months. And then next year, when we have generation 4 capability, that's basically going to cut that time in half once again. Over.
Awesome. I will chime in and say that I think one of the interesting ConOps that we build over time is the whole idea of tipping and queuing and starting with an event and then pulling, like Gur showcased, the relevant images and maybe even to create a chain of custody through time to see how it evolved. And this kind of caters to another question that I think is spot on. It's about chain of custody, and specifically the way it was put is how can you track vessel route when it goes dark? Matthew, you want to start? Maybe. I know that you like this topic a lot.
I do. I mean, let's face it. If bad guys are doing bad guy things, they're going to find ways to limit their potential for being detected. And in some of the case studies that we've done, which I guess alluded to some of the other questions, that there are more case studies that we worked on, but really is that using, in this case, I leverage Windward's maritime insights protocol to identify pattern of life of these vessels, right? So what have been their most common path that they have taken, whether it's in brown water or blue water domains. And then what we do is we try to assess which one of those paths those vessels are most likely to take. And I overlay that with the next passes of our ICEYE satellite constellation. And then I try to time the speed and heading of that vessel about where it was last known and the direction, and then try to do a little bit of math to identify the best time window to task that ICEYE SAR collection. And that's what we did, I think, in one of those images too, where we got the ship-to-ship transfer that was in one of the images that I shared. We were tracking one of those vessels due to some nefarious behavior, and it went dark, and we were able to be very fortunate and able to acquire the image. And it just happened to be when we acquired that next image, it was during a ship-to-ship transfer. So kind of tip and cue is that it went dark. We used the analytics. We've identified where it was probably heading based off of its direction and speed, and timed that SAR acquisition very reasonably well. And we're able to get a nice, clear picture to corroborate our analysis. Over.
Yeah, and we know how you like math, so that's always a fun point.
Yeah, math for Marines. It's always it's like watercolors and crayons and pointing, grunting.
Awesome. Marc, do you want to add your thoughts on that as well?
Yes, also on our end, the way we approach it is mainly with wide area monitoring, and that's enabled through our PlanetScope constellation, which is monitoring almost the entire landmass every day. So it's able, like when that ship goes dark, we're able to, and that's the job that Windward does, but on our end, we can also track AIS coordinates to archive imagery. We have a vast amount of archive images, and I think that's one of the main proof points and unique selling points of Planet also, because it helps you to build the story, where that boat has been before, and you can have that visual clue all the time at the initial point, matching the AIS coordinates, and then at some point having a switch off of the AIS and see that that vessel has been moving across the sea. And then having that idea of analytics and detecting that boat and predicting that route and checking that route visually, we can also enable with the tip and queue. We have the option of tasking at specific times of the day on a specific dates with the SkySat imagery, allowing you to really get an image of what is the expected position of that vessel at that time, and really then corroborate it and double check it with the AIS coordinates and see that something has happened and that boat has been moving unreportedly, and also with the high resolution allowing you to detect features of that boat and determine the class and then corroborate it with the databases that you have available.
Awesome. Appreciate it, Marc. Gul, any remarks from your end? Do you want to try maybe and give your perspective?
So first of all, I'd like to cover that, tracking dark vessels is always problematic and a tough case to do. This is why you need to harness the power of maritime AI and predictive analytics to better understand where the potential locations of those vessels, classic tip and queue. Now, it is so we can overcome the gap between the assumption to the validation by the integrations that we already have with our partners here, whether it's with Planet that we have the seamless integration, so every asset that's available may be available to our customer in the relevant package for easy consumption. And I can only give my testimony that the availability of imagery just increases over time as there are more satellites in orbit, which is amazing. In the course of the past 5 years when I'm here at Windward, the amount of assets available are just remarkable. Secondly, also with ICEYE, whenever our customers wishes to task the SAR images from ICEYE, once the asset is obtained in and on Earth, it will be automatically available in the system, so you can close the gap and close the circle in a really fast pace that I'm not even sure that even military organization can close the circle that fast as those commercial companies with us together.
Hey, Gul, I think that's a really good point, right? Is that the multiple phenomenologies or multiple remote sensing, whether it's ICEYE or Planet or elsewhere, are all, after they're downlinked and post-processed, they're seamlessly integrated into the Windward common operating picture, right? So as you provided in your demonstration, obviously you're able to pull up that data and have that seamlessly involved. So regardless of the several file formats that both organizations provide, it's seamlessly integrated in there. It's at the fingertips of the end user, and it's readily available to provide their own analysis on in conjunction with the maritime insights that Windward provides. Over.
Yeah, appreciate this comment. And by the way, absolutely the same goes to SkySat, high-res for Planet. And I think that one of the last thing that worth mentioning is kind of what the future holds. And I think we're just starting, and it's really impressive to see what was achieved so far, and definitely what can be achieved going forward when all three companies working not just together, but also pushing the boundaries of the capability and really addressing some of the challenges that we spoke about today. We are reaching to the end of our time. I would like to sincerely and deeply thank my dear friends and colleagues from those great companies and partners of ours. So Mr. Morris, thank you so much. Mr. Peña, thank you so much for taking the time. Gur, thank you for prepping, and to the entire team that work of making this webinar possible. To all of you that submitted questions that we didn't have time to answer, we'll make sure to follow up via email. please feel free to reach out to each and every one of us individually for any follow-ups. I'm sure that the details of both Planet with Marc and ICEYE with Matthew can be shared. So again, thank you everyone to participate today. We highly appreciate your interest and looking forward for the next opportunity. So thank you all. Enjoy the rest of your day. Cheers.